Hello there and welcome back. We have to solve this trig equation where the domain is plus or minus infinity, all real x, or all real theta. So let's see what we can do with the trig ratios sec square theta plus sine square theta is equal to 5. So what we can do is we can write 1 over cos square theta for sec square theta, and for sine square theta we can write 1 minus cos square theta, since we know sine square theta plus cos square theta is 1. So let's put that together. So we can say 1 over cos square theta plus 1 minus cos square theta is equal to 5. So we have one equation in all cos. Let's simplify this a little bit further, so it would look more like a quadratic equation after substitution. So if you multiply by cos square theta for all the terms, we get 2 into cos square theta over 1 minus 1 over cos square theta will be 2, plus 2 into cos square theta minus 2 cos to the power of 4 theta. That is because cos square theta times cos square theta will be cos to the power of 4 theta. Similarly, on the right hand side we have 5 cos square theta. Let's collect all the terms on one side. We have minus 2 cos to the power of 4 theta. We have minus 5 on this side. We have minus 5 plus 2 is minus 3 cos square theta plus 2 is equal to 0. Let's multiply by minus 1 to make it neater, with the leading term being positive. 2 cos to the power of 4 theta plus 3 cos square theta minus 2 is equal to 0. Let's do a little bit of substitution to make it look like more like a simpler quadratic. Let cos square theta is equal to t. So we get 2 2t square plus 3t minus 2 is equal to 0. Now let's try and find the factorization for this. This is 2 and 1 using cos method. We will say that we need plus 2, so 2 and minus 1 should give a 4 times 2 times 2, 4 times minus 1 is plus 3, so that is 2t minus 1, and we have t plus 2 is equal to 0. That is, with the null factor method we say 2t minus 1 is equal to 0, or t plus 2 is equal to 0. Substituting back cos square theta, that is 2 cos square theta minus 1 is equal to 0, or cos square theta plus 2 is equal to 0. So let's find the value of cos square theta. So we have here cos square theta is equal to half, or we have cos square theta is equal to minus 2. This is not possible, as a square term cannot be negative, so not possible. We will have to discard this solution and we will have to work with this. So we get cos theta is equal to plus or minus 1 on root 2. That is possible for theta is equal to pi by 4. So if you see a square of 1, this is pi by 4, and this is root 2. So cos pi by 4 will be root 2. Therefore theta, acute angle theta will be equal to pi by 4. Now this one we say plus or minus. So if in case we look at plus cos theta, we will be getting on this side, so it will be that angle. And if in case we say minus cos theta, will be this angle. So this angle is 3 pi by 4. So pi by 4 and 3 pi by 4. Right, so that is that angle and that angle, because we have plus or minus cos theta. So it's first in the second quadrant. Now since we've been asked to find the general solution since they're asking us to find the general solution, which means that we have to consider the cyclical nature, the periodic function, or the trig periodic function, and we know for cos theta the period is 2 pi. Now it will repeat for the first time. We will say, let's say we repeat first value counterclockwise, second value counterclockwise, and we go back and find the third value. So if in case we consider just the first value, if we consider the first value and we go back, we basically are adding 2 pi on top one time. So 2 pi, and then we add another 2 pi, right? So we'll have to call it, my answer, my solution will be 2k pi. I'll declare what k is equal to, plus pi by 4 and 2k pi plus 3 pi by 4. So basically we will have not exactly and, we will have all these will give me the solutions for theta is equal to 2k pi, where k belongs to integers. It can be plus or minus, because we can also go in the clockwise direction as well, right? So that we will be finding the negative angle. So this is the solution for the general solution for this problem. Thank you so much for watching. Post any questions on the comments, and see you next time in the next video. Thank you so much. So adding on to the plus and minus, so the theta, the general solution will be pi by 4 plus or minus 2k pi, or 3 pi by 4 plus or minus 2k pi, where k belongs to integers. Thank you.